All right, continuing on here. Um, I mentioned the camel case that we use with our variables. With a public variable, one that shows in the inspector, if it's lowercase test, capital var, we'll see that in the inspector, it does a funny little thing for us. Here's my script that has the test var in it. And when I see this in the inspector, it's capital T-E-S-T blank VAR. So this is what it uses the camel case for. And it's worth being aware of this in that when we go to access test var from another script, which we'll do all the time, we have to access lowercase test capital var, even though it shows in the inspector as capital test blank capital var. It's just the way Unity works. So as I mentioned, we can store values here. So I can put a value in here, and that overrides whatever the value is that was in the script. There's nothing in the script here, but I've put a 5 in there so that test var has a value of 5. Add to this little function an awake function. Awake is executes when the object comes into existence, and this little condition is going to say if the test var is greater than 5, I'll print that 5. Otherwise, I'm going to print too small, and I believe this will do that. The printing goes over to the console here. So if I put a 6 in here and run this, I should see something appear over here in the console. There's the 6. If I put a 4 in here and I run this, it'll tell me that it's too small. So those kind of display of things that we see, we're printing a number here and we're printing a string here, those all work. We can access various components of our object. I'm going to get the component, the renderer on it, and I'm going to turn it off. So if I think that's, if I get that script, so I can add this get component render enabled as true for test var greater than 5. Otherwise, when I do the too small, I'm going to set the render to false because I already had that in there. So now that it's too small, you'll notice that the object disappears. Whereas when I had the 6 in there, the object does not disappear. So accessing different components is pretty easy. We can also have arrays. Here in this case, I'm going to not save that. In this case, I've changed that variable to be an array. Change the name of it as well, but basically including these square brackets after the test var. Test var is now an array. And I can add to this how big I want this array to be. If I say 5, and my array now has 5 slots in it, and if I run this, I'm not sure what will happen. It loaded a bunch of integers into my int. um, oh, this is an awake 2, I'm sorry. Awake 2. Sorry. Awake 2. So now the cube here, here's test bar, has 5 items in it. And we now have elements 0 through 4. If I go through a loop in here and test these things to see which of these elements of this array, this is a loop from I equals 0 to the length of the array, which is 5. We're going to, if the entry of the array is greater than 5, I'll turn this off. This only really cares about the last value. So if I make this 6, this should do something, turns it off. If this is 4, it'll leave it on. Oh, if this is 4, it'll leave it on. I have it backwards. If this is 6, it will leave it on. 6. Sorry. That was a feature that you might notice. If I change something while it's running, it does not keep it. So I changed that while the script was running. And when I ended the run, it reverted back to its original value. So now I have a 6 in the 4th element, and it stays on as predicted. If I move this stuff into the update function, I will see it. I will see it. If I move it into the update function, I will not. This is happening every game cycle, and so if I run this and I change the value of this element to 4, it disappears. If I change it back to 6, it reappears. That's because this test is now going on in the update function as opposed to in the await function. And also note the values set while the game is running are not permanent and will be reset when the game ends. So it goes back, reverts to its original values. We have some random number generators. Random range 0 to 6 will pick numbers in the range from 0 up to but not including the 6. So this will get 0 through 5. And we also have other mathf functions like sign. Have a look at the scripting reference for this. Now in this awake function, now using the cube controller 3, the cube controller 3 has cube controller 3 uses sets random numbers in the awake function in the range 0 to 10. So, and then in the update function goes through and decides whether to turn things on or off or not. So if I run this, I will see random numbers generated here for test var. Random numbers. We ended with a 6, and so it left it visible. Let me see if I can get it to make one smaller there. So that time randomly it got a 0, so the thing disappeared. Random numbers. Very useful. Data types, as I mentioned, we have ints, floats, booleans, rects, vector 3s. A boolean is bool, a vector 3 with its constructor new vector 3. And with a vector, we can access the whole thing, doing things with the whole vector, or we can access its individual elements, its x, y, and z elements with .x, .y, and .z. An example of doing something like this is with a transform and its position. We can make an object move with time. So I make a copy of the transform position, which is a vector 3, x, y, and z values. I'm going to modify its x position by subtracting out cube speed, and then I reassign this temporary back to the transform position. Cube speed might be a public variable exposed in the inspector that lets you set the speed. The following is a little better in that it moves cube speed per second rather than per frame, and this uses the time class, time.delta time, which is the time of the last frame that the game rendered, which kind of gives you an indication of how fast the game is playing. And so multiplying cube speed by this fractional second time that the last frame rendered means that our object is going to move at cube speed per second as opposed to cube speed per frame, which could lead to erratic movement. Also notice that minus equal 1 is the same as x equal x minus 1, just in case you haven't seen that construct. Also, this doesn't work. You can't say transform.position.x minus equal cube speed. You'll get an error if you do this. You must make a temporary, modify something in the temporary, and then store it back. That's because the transform position is a struct. Dealing with this non-uniform time rate, time delta time is the time between frames. 5 times time delta time will make something move at a uniform 5 meters per second as opposed to 5 meters per frame. And I'm going to pause again there, and I'll pick this up in just a minute. So let me end recording, and I'll see you in class. Bye.